All right, in which of the following species is the central atom likely to violate the octet rule? The bold atom is the central atom. Now, as we get more comfortable doing Lewis structures, there will be certain times that this is far more obvious. When we're first starting, the best way to figure this out is to actually do each one of the Lewis structures. So A, remember, we're always going to do these the same way. So we figure out the valence electrons all together, and then we just go from there and build our little molecules. And on boron trifluoride, once I get to have all my dots around the fluorines, we will find that we are done and we're out of electrons. And if we check the formal charge, the only thing that doesn't have a formal charge of 0 is the boron in the middle, and it actually has a -1 formal charge. And then we just put the entire molecule in brackets and put a negative molecule there. So the central atom, the boron, has 8 electrons it sees, or 4 bonds, so it is following the octet rule. Now, xenon, right off the bat, is a doubtful one that it's not obeying the octet rule simply because it is a noble gas, and most of the time, if they get involved in bonds, they break the octet rule. All right, if I actually distribute all my electrons on xenon trifluoride, or trioxide, get to about right there. Is that all my electrons? 20, yeah, that's 26 valence electrons. I have them all out. Now, if I leave it like this, everything's following the octet rule. But right now, each one of these oxygens is a -1. And that xenon in the middle is 8 minus 1, 2, 3, 4, +3. We don't like any one of those. So what we're going to do is start by getting rid of those. We can fix this. What we're going to do is take those two and make a bond. Take 2 here, make a bond, and take 2 here. Really didn't want to erase those, did it? And make a bond. All right, that gets all the oxygens have a formal charge of 0, and the xenon has now a formal charge of 8 minus 1, 2, 3, 8, so 0. That is the acceptable Lewis structure of xenon trioxide, and it does have xenon breaking the octet rule. So B is our correct answer. We can go ahead and circle it. But just to get the practice, we're going to do the remaining Lewis structures. Silicon trichloride, we're going to find after we distribute all of our electrons. Let's see, there's going to be 28, 32 valence electrons. So I got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. All distributed, all 32 valence electrons. Silicon has 4 around it. It's perfect, or 8 around it, so it's perfectly following the octet rule. D, and we need to put 2 more electrons on there. Put a little pair of electrons on nitrogen, and everything's following the octet rule and has optimal formal charges. All right, and last one, CH2, Cl2. Something like this, and we're out of electrons. And everything's following the octet rule, and everything's got optimal formal charges. So B is our correct answer. The xenon is not following the octet rule.